Good day and welcome to Big Bad Tech. I'm your instructor Jim Pytel, and today's topic of discussion is AC voltage, frequency, and period measurement using a digital multimeter, or DMM. Our objective is to take a quick look at the AC voltage, frequency, and period measurement function on a representative example of a commercially available DMM. If you recall, way back in the Basic Electronics 1 DC Circuit Analysis playlist, I introduced various functions of the DMM, including the ohm meter, the DC voltmeter, and the DC ammeter. Today we'll continue in this fashion to explore additional functions offered by most commercially available DMMs, including the AC voltage, frequency, and period measurement function. For the purposes of today's lecture, we'll be making use of the BK Precision2831E DMM. This in no way is meant to be neither an exhaustive review of this DMM nor an endorsement of this particular manufacturer or model. I only wish to present the functions of interest on a representative example of a DMM so the viewer can gain some practical exposure to these functions and interpret the manner in which results are displayed. Let us begin. First, let's discuss some of the characteristics of commonly available voltage in the United States. The U.S. electrical distribution system is characterized by several distribution voltages, among which is a residential single-phase AC, characterized by a frequency of 60 Hz and an effective or RMS value of 120 volts. This voltage peaks out at 169.7 volts, has a peak-to-peak value of 339.4 volts, and a period of 16.7 milliseconds. Let's use the BK Precision2831E digital multimeter to confirm these characteristics. Upon powering up the BK Precision2831E, we see it does a quick functions check and immediately defaults to the DC voltmeter function. Place the DMM in AC voltmeter mode by pressing the AC voltage function button on the upper right-hand side. The manual for the BK Precision2831E shows this particular DMM is limited to measurements of voltages below 1000 volts peak or 750 volts RMS. The voltage range we intend to measure is well below these upper limits. Now that the AC voltmeter function is selected, we need to insert the leads. Black lead into the black common hole. This is the lead that will be used as our reference. Red lead into the red hole, indicated with a V, the shorthand for units of volts, over it. Yes, you can put a black lead in a red hole, and you could put a hat on your foot, but that is not its intended purpose. The BK Precision2831E DMM is auto-ranging, so we don't need to worry about manually ranging it prior to measuring voltage. Isn't that great? Note you can force it out of auto range mode into manual if you want to, but we're going to keep it as is. Now, all we've got to do is place the voltmeter leads across our terminals of interest. Inserting the probes into the top two holes of a socket, the DMM displays a voltage differential of approximately 120 volts, exactly as we'd anticipated. Note the DMM is displaying the RMS or effective voltage of this AC voltage waveform and not the peak or peak-to-peak value. I say again, all DMMs, all the time, always measure RMS or effective voltage unless explicitly forced into performing some other function. Note our socket has 3 holes, and as currently illustrated, this DMM is measuring an effective differential of 120 volts across the top 2. If we swap the location of the leads, note the DMM still measures an effective differential of 120 volts. This is to imply that polarity is of little concern for an AC voltage source, since voltage regularly swaps polarity. The hot connection has an effective differential of 120 volts with respect to the neutral connection, just as the neutral connection has an effective differential of 120 volts with respect to the hot connection. With respect to the grounded third hole, note we observe a hot connection still exhibits an effective 120 volt differential. Whereas, with respect to the grounded third hole, note the neutral connection exhibits no differential. This is to imply that the neutral connection is ground referenced. The ground connection is used to ensure that the powered item remains touch safe and maintains the same potential as that which an operator is quite literally standing on. Additionally, a ground connection ensures fault protection devices like fuses, circuit breakers, and ground fault current interrupters function as intended. While we're here, let's measure the frequency and period of this AC voltage waveform. Returning the leads to the hot and neutral connection, we can place the DMM in frequency measurement mode by pressing the freq function button immediately below AC voltage. As anticipated, this AC waveform has a frequency of approximately 60 Hz. If we wanted to determine the period of this AC voltage waveform, we could calculate it by taking the inverse of frequency, However, the BK Precision2831E offers the means of directly measuring period using an alternative function. To access the alternative function set, press the light blue Shift key in the lower right. Note the period selection written light blue above the freq function. As anticipated, this AC waveform has a period of approximately 16.7 milliseconds. Alright, that's about it for this quick demonstration of how AC voltage, frequency, and period are measured using a DMM. We'll make use of this tool in later lectures to verify the output of function generators and the electrical characteristics of elements within AC circuits. Note the DMM displayed a numerical result consistent with our expectations. However, the DMM never went to the trouble to draw out the AC waveform on the display. We'll examine a tool called the oscilloscope in later lectures that, in addition to displaying numerical values, can also display a graphical representation of the AC waveform under inspection. In conclusion, this lecture took a brief look at the AC voltmeter, frequency, and period function on the BK Precision2831 digital multimeter. We used the DMM to confirm the characteristics of commonly available residential single-phase AC. Remember to review these concepts as often as you need to really drive it home. Imagine how well lab will go if you know what you're doing. Thank you very much for your attention and interest, and we'll see you again during the next lecture of our series. Remember to tell your Lazy Lab partner about this resource, and be sure to check out the Big Bad Tech channel for additional resources and updates.